Welcome to Atlas Protocol. Let me walk you through our complete architecture. At the top, we have our React frontend that users interact with. It connects to 3 key integrations: ConnectKit for wallet connection, World ID for Sybil-resistant verification, and Owlto Finance for cross-chain functionality. The front-end communicates with our back-end service built in TypeScript. This service is the brain of our application. It connects to 3 critical components. First, the Story Protocol SDK. This is how we interact with Story Protocol's official APIs for IP registration and licensing. Second, Goldsky Subgraph. This provides real-time GraphQL indexing of all on-chain events for CVS calculation. Third, our smart contracts deployed on Story Aeneid Testnet. On the blockchain, we have 3 main contracts. Story Protocol Core.sol handles IP registration, licensing, royalties, and derivatives. ADLV.sol manages IP-backed vaults and CVS calculation. Lending Module.sol enables IP-backed loans. This architecture allows us to transform IP assets into financial instruments, the core innovation of Atlas Protocol. This is the mint and register IP asset function, the core of our Story Protocol integration. Here's what it does. First, it generates a new token ID by incrementing our counter. Then, it creates a deterministic IP ID using a KEKIC 256 hash of the timestamp, recipient address, token ID, name, and content hash. It stores the IP asset in our mapping with all its metadata. Finally, it emits an IP asset registered event that our Goldsky subgraph indexes. This function mirrors Story Protocol's IP asset registry, allowing us to track IP ownership on-chain. The royalty module handles revenue distribution. IP owners call set royalty policy to configure how royalties are distributed. Beneficiary, who receives the royalties. Royalty percentage. The percentage in basis points, 10,000 equals 100%. The contract tracks total revenue and claimed revenue for each IP. When someone mints a license or creates a derivative, royalties flow automatically to the beneficiary. This is critical for our CVS calculation. The more royalty revenue an IP generates, the higher its collateral value. This is the derivative registration function, one of Story Protocol's most powerful features. When someone creates a remix, adaptation, or derivative work, they must hold a valid license token from the parent IP. The derivative is registered as a new IP asset. A permanent parent-child relationship is created on-chain. The key innovation here: when the derivative generates revenue, royalties automatically flow back to the parent IP owner. In Atlas Protocol, derivatives increase the CVS of the parent IP. More derivatives mean more collateral value. Now let's look at the backend integration. This is our Story Protocol service, written in TypeScript using the official Story Protocol SDK. The backend serves as the bridge between our frontend and the blockchain. The constructor initializes the Story Protocol SDK. Key configuration: RPC URL connects to Story Aeneid Testnet. Chain ID 1315, Story Protocol's testnet identifier. Story Client, the official SDK client for all Story Protocol operations. Once initialized, we can call any Story Protocol function directly from our backend. This is how Atlas Protocol achieves 100% Story Protocol integration. We use the official SDK for all blockchain interactions. This is the mint license tokens function. When a user wants to license an IP, licensor IP ID, the IP they want to license. License template. We use Story Protocol's default PIL template. License terms ID. The specific license terms to apply amount. How many license tokens to mint receiver? Who receives the tokens? The function calls Story Client. License. Mint license tokens. A direct call to the Story Protocol SDK. Each license sale is recorded on-chain and indexed by Goldsky for CVS calculation. The register derivative function links child IPs to their parents. Notice how we support multiple parent IPs. This enables complex derivative chains where one IP can be derived from multiple sources. The SDK handles all the complexity. We just pass the parameters and Story Protocol manages the relationships on-chain. For Atlas Protocol, each derivative adds to the parent IP's CVS, increasing its borrowing power. Let's verify our deployed contracts on StoryScan, Story Protocol's Block Explorer. Here you can see our Story Protocol core contract at address 0x825b, A5. The contract is verified and you can view all the source code, read functions, and transaction history. This transparency is essential for hackathon judges to validate our integration. Here are all our deployed contracts on Story Aeneid Testnet, Story Protocol Core, the main integration contract. ADLV, our vault contract for IP-backed collateral. Owlto Oracle, the CVS oracle that calculates collateral value. Lending module, enables borrowing against IP assets. Story SPG, Story Protocol Gateway integration. All contracts are verified on StoryScan and fully functional. Now let's query real data from our Goldsky subgraph. Goldsky indexes all events from our smart contracts in real time. You can see here, license sales, 3 commercial licenses sold at 1.5 Story each. Loans, 6 loans issued, 5 repaid, 1 currently active. This data powers our CVS calculation. The more license revenue an IP generates, the higher its borrowing power. This is real on-chain data, not mock data. Everything you see here happened on Story Protocol's testnet. To summarize what we've built with Atlas Protocol, Smart Contract Layer, Story Protocol Core.sol provides complete Story Protocol integration, IP registration, licensing with PIL framework, royalty distribution, and derivative tracking. Backend Layer uses the official Story Protocol SDK for all blockchain interactions, ensuring 100% compatibility. Data Layer, Goldsky subgraph provides real-time indexing for CVS calculation. The result: creators can now use their IP assets as collateral to borrow funds, without selling their IP. Atlas Protocol cannot exist without Story Protocol. It's our foundation for IP identity, ownership, licensing, and revenue tracking. Thank you for watching. Try the live demo at the link below.